Scientist Dr. Noel Schulz, Schweitzer Chair, School of EECS, Washington State University, Pullman, and Chief Scientist, Pacific Northwest National Laboratory. She has been a Chief Scientist at the PNNL since February 2020, serving in the joint appointments as part of PNNL Advanced Grid Institute. In August 2021, she became co-director of AGI after serving 18 months as interim co-director. She received her BSEE and MSEE degrees from Virginia Tech, Blacksburg, VA, and PhD degree in EE from University of Minnesota, Minneapolis, MN. Dr. Schulz has been active for over 26 years in teaching, research, and service at 6 US universities. In research and graduate studies, she has graduated 45 MS and 15 PhD students, published 175 papers and 2 book chapters, and brought in over $40 million in external research. Her research interests include integration of DER into distribution systems and microgrids, including storage and electric vehicles, intelligent system application in power system design, control, and operation, outage and storm management, including smart metering and resilience efforts and shipboard power systems. She has been active in the IEEE Power and Energy Society and served as IEEE PS President in 2012 and 2013. She has been a recipient of the IEEE PS Walter Fee Outstanding Young Power Engineer Award and National Science Foundation Career Award. She is a fellow of IEEE and ASEE. In 2021, she was elected to the Washington State Academy of Science. In addition to her technical activities, Dr. Schulz has been very involved in activities related to the recruitment, retention, and advancement of women and multicultural students and professionals in STEM careers. She is also an advocate for advancing the power engineering workforce. We are very happy to have you, ma'am, for this today's session. We welcome you to the session, ma'am.
Thank you very much, and thank you so much for the invitation. I was very excited to be able to visit with you all this morning. So I'm going to try to share my screen again and see if we can get that to work. Okay. So now something's not working here. There you go. Okay, can you see my screen all right?
Yes, ma'am. Yes, ma'am.
All right.
Fine.
Okay. So good evening, everyone. Thank you so much for being here today. It really is an honor for me to talk to you about building resilience and power systems and in each other. And I really look forward to the discussions as well and questions. And so feel free if you have questions. I can't see the chat. So if one of the moderators, if there's a question, or someone can make sure and let me know.
Sure, ma'am. Sure, ma'am.
Thank you. So this is a little bit of an outline of what I'll be talking about today. So first, I'm going to share a little bit about my background. Then I'm going to talk about building resilience for the future power grids, then building your leadership and resilience skills, and then a summary and then Q&A. So this is a little bit about my family. On the left, you see my parents. My mom was an elementary school teacher, and my dad was electrical engineering professor. And this picture was taken at the PES meeting when I became an IEEE fellow. So it's very nice to have my family there to help celebrate. And then on the right, you see my husband, Kirk, is a chemical engineer, and he's also president of our university. And then my older son, Tim, is a computer scientist, and he and his wife, Trisha, are both computer scientists. And then my younger son, Andrew, is a PhD student. So very familiar with being a graduate student and some of the challenges and opportunities related to that. But a couple things that with my parents that were important as we start to talk about resilience in you yourself is my dad always talked to me when I was in high school. He said that he wanted me to have tenacity, which I didn't really know what that word meant, but really tenacity is really resilience, is being able to stick through things and to make it through challenges. And my mom said, as after college and as I was going into my first job and leaving the area where my parents lived, She encouraged me to make a difference. And these are some things that I've kept with me throughout my career. And we'll talk some more about those. So this is a timeline, and I put this for a couple different reasons, and I'm not going to explain this whole thing, but I share this because as we move into 2022 and beyond, we're seeing a lot of dual career couples and a lot of couples that are both trying to have careers. And so I share this related to some of the opportunities we've had to work at different universities, and to have advancement, to have opportunities both at universities for leadership as well as within a professional society. And so you can really see some different aspects here of our paths along the way. And that really just, I think, can help people see that along the way, there transitions that you make and you work together on those transitions along. And also a little bit more about my background. As was mentioned, Virginia Tech for my bachelor's and master's. I taught at Virginia Tech for a while, then University of North Dakota, got my PhD at Minnesota, and then I've had a chance to teach at Michigan Tech, Mississippi State, Kansas State, and now Washington State. So I think it's important for you to kind of know my background so you know where I'm coming from as we talk about some of the different things, particularly about resiliency for yourself. So as was mentioned, in 2012 and 2013, I was president at IEEE PES, and you all know about IEEE PES. But over those 2 years, I traveled over 240,000 air miles over 6 continents. We didn't have any PES meetings in Antarctica, but it really was a great opportunity for me to interact with students and engineering professionals from around the world. And there were 2 activities that were very important to me. One was the Women in Power, and we'll talk a little bit more about that. And the other one really is the PES pipeline. And I think this is really important because, you know, as we grow as an organization, it's important that we have programming and activities across PES, no matter where you are in your career path. And this is a little bit of older picture, but the young professionals, that you have ways when you're first entering your career, that you have some different networking sessions such as this, webinars, ways to learn from those that are ahead of you in their careers. We also want to have stuff for mid-career folks to help them advance and get into leadership and get into management. And then also the leaders, as well as trying to make sure we have opportunities for students, K through 12, both younger students as well as college students. And this is really important as we think about PES, making sure we're going across the whole spectrum. So Women in Power was one of my big things that I was interested in. And so what I was able to, I had an opportunity to do is to have some of these Women in Power events over 6 different continents. And these are pictures of 2 that we had. One in Bangalore for, I think this is ISGT in 2013. And then I also worked in Ethiopia with a conference, Africon, where we had over 100 women from across Africa. So, you know, this is a real passion of mine, is finding to make sure that we continue to have women involved in engineering to help us look at different perspectives, as well as just have opportunities to learn more and to help advance the power grid. You know, one of the big things I learned partially in those 2 years as PE as president was how to learn through travel. You know, and that's been a real hard thing the last 2 years, not being able to travel the way I did before COVID. So looking forward to doing that again. I've been to 48 of our 50 states. I haven't been to New Hampshire and Vermont, my 2 states. I've lived in 7 states across the US, and their differences, just as you all see in India, differences between northern India, southern India, other aspects of different parts of the country. I've had a chance to travel to all 7 continents, and I've spent a sabbatical in UK, in Wales, in 2008 for 4 months, and got to see a different way of living. And then I've had a chance to visit 37 countries outside the US, and I really learned a lot through that. And one of the special things I was able to do in 2019 is spend 4 weeks in India. And that was I learned a lot. I got to do some sightseeing and interacting, visiting with students about different festivals and talking about different traditions in India and different parts. I happened to be there during wedding season, as they called it, around Delhi, and to see some of the different practices around the country was really, really interesting. And it's something I think you can learn a lot along the way. All right, so that's a little bit about me. Now I want to talk more about building resilience for future power grids. And as we look at 2020, we had a lot of challenges. We had a lot of storms and natural disasters that we had in the Atlantic that affected parts of the U.S. and other regions. We had wildfires in Australia and in California that created challenges related to the grid. We also have challenges around too much water or not enough water. As you see this picture of some flooding, and then you see a picture of a U.S. map where we see drought in certain areas of the world, or certain areas of the U.S., and how that really affects, particularly as we look at hydro energy and look at hydro that we're using in those regions. But it also means challenges that can sometimes create wildfires, and we've seen some of that. Then in 2021, we had some additional challenges related to Texas, had some challenges where the power grid failure. We had the heat bubble where in parts of the Pacific Northwest and Washington State, we had rolling blackouts because of grid challenges. So one of the things that came out in 2021, and I encourage all of you to look at, was a report by the National Academies of Engineering that came out on the future of the electric power in the United States. And one of the things the U.S. Congress had asked the National Academies to look at our grid infrastructure because it was so important, and to see what the challenges were coming up. And this report is available online, and I can provide the PowerPoint so people can also click on the links and see that. But one of the things of the 5 needs that are talked about in that report, the second need was to ensure the electricity service remains clean, sustainable, reliable, and resilient. And if you talk about these are, as we talk about engineering and we talk about optimization, sometimes when we optimize some things, it's very hard to have a multi-objective optimization. And as we look at trying to be clean, and we'll talk about some of this, trying to be sustainable, reliable, and resilient. And these are some of the challenges we've found is as we add renewables, solar and wind, that are non-dispatchable generation, how do we balance that with the need to be able to be reliable and resilient? And so sometimes these are counteracting each other, and we'll talk more about that. So when we talk about resilience related to the power grid, we talk about, I think about, we've heard this word a lot lately, and we hear it a lot. And if you went on IEEE Explorer and did a search on resilience or resiliency, you'd find a lot of papers have come up recently in this area. So I kind of went back and looked at this, and I really love this picture because it helps define in a picture what resiliency is. And the task force has definitions and quantifications of resilience. And so you can learn more about that on the IEEE technical report. But the definition is the ability to withstand and reduce the magnitude and or duration of disruptive events which includes the capability to anticipate, absorb, adapt to, and or rapidly recover from such an event. So, this picture is, I really love because it that comes from this article that's down there that shows the fact that what is resiliency, right? So basically what resiliency talks about, that you're in a certain state, some event happens and you go to a degraded state, and then you might restore it. You might restore it partially, and then you're in kind of a restored state, but not all the way back up to where you were before. And then you've got the infrastructure recovery, where you get all the way back to where you were before. And you can see the different times down here and talking about that. And there's a couple important things as we look at this. So one of the important things when we talk about resiliency is how we're prepared ahead of time to be able to recover quickly, that we have the resources, or we have the system is designed to be able to recover quickly. And one of the things that happens in the US when we have a hurricane coming is a lot of the utilities, they take trucks and they park them, the people drive to right around the borders of where the hurricane's supposed to impact, and they wait there till the hurricane's over, and then they move in to help restore. And that's basically a resilience technique where we're preparing for that. But the other important thing here is sometimes with what you want to try to do is shorten this time from here to when you restore, all the way restore. But also another important part of this is we may restore some things and then after a while go back to the original. And we'll talk a little bit about that. And I think it relates to as we talk about microgrids, as we talk about moving forward. All right, so when you start to talk about resiliency, there's a lot of different topics you can talk about, right? We can talk about wind, we can talk about solar, we can talk about storage. So this, that comment I had is we want to have clean, sustainable, and wind and solar. We've got storage. We then can also talk about advanced distribution systems, microgrids, looking at markets, looking at how do we manage energy management, standards and policies. And then we've got protection, sensors, cybersecurity is an important part. And then when you start to look at all these topics that I have up here, first we want to kind of set up some tools and benchmarks, then we put them into the lab, and then we want to take them out to field demonstrations. So, and then we also have to look at something that's important for us as engineers is to look at the social acceptance and impact. Are people accepting of the technology and the capabilities of windmills, solar, storage, and then workforce? We see a lot of engineers, power engineers close to retirement. So how do we make sure we can, we're going to have the workforce we need? And so this really, then on top of that, we add two perspectives. We add the India perspective and the US perspective, because they're different. As we look at some of these, they're different workforce challenges and opportunities, social impact and acceptance, all of these things. And that's really what our project UI Assist is, that I'm going to talk about, the technical side. And I just want to check and make sure you're all still there. Everybody can hear me okay? Can someone unmute?
Yes, ma'am.
Okay, good. No, I can't see, I can just see my screen. So I worry, I don't want to be talking to myself. So thank you.
Yes, ma'am.
Carry on, sure.
Yeah, so so there's the Clean Energy Research and Development Center, which is a U.S.-India joint project. And it's really a way that we work together with the U.S. and India to look at clean energy related projects. And there have been 4 different efforts in that area. The first 3, solar, biofuels, and really what we would call smart buildings now. And then in 2017, our project, which we call UI Assist, was a $30 million project with $7.5 million from U.S. Department of Energy, and then $7.5 million from the Government of India, Department of Science and Technology, as well as matching funds. And then Indo-US Forum, Science and Technology Forum, helps implement this and works with us together. So it's a very large project with people from all over the world, and literally, we have a lot of different groups in India that you can see here. We also have a lot of different entities across the US and that are working on this project. And one of the things that's interesting is we have universities, we have national research labs, we have companies, we have utilities. So lots of different perspectives here. All right, so a little bit about UI Assist, the background related to it. So, and this is kind of the really high level of the project. And you can imagine with 30 partners, there's lots of different things moving around. But our goal is to look at future distribution grids and look at how to integrate distributed energy resources towards sustainable electricity systems, including optimization. How do we optimize and manage those distributed energy resources in a secure manner? How do we interface the resources, microgrids, controls, as well as distribution, as we have a higher and higher percentage of also energy storage? And also, how do we develop and demonstrate the different operations that we see related to distribution system operations? So there's a lot of different aspects of this project, and that we can talk about those many different aspects, but I'm going to just kind of give an overview of some of the different topics. So we've kind of broken it down into 11 different themes where we break the topics down. And the topics range from energy storage, looking at how do we use energy storage. We also looked at microgrid and distribution, active distribution systems, controls, protection of the grid, and how do we look at microgrids differently than if it's an attached distribution system. Cybersecurity is kind of in two aspects. One is cyber infrastructure, as we look at communications, the physical layer, security, as well as sensors. Where do we put sensors to get the information we need? And then obviously cybersecurity to keep things safe. We also have distribution system functions for optimization, which is scheduling, reliability, volt-var control, looking at PV, wind, and load forecasting. You know, because PV and wind are not dispatchable, forecasting becomes so important to try to use them as part of a sustainable power system. And then we have to look at regulations. And also markets on the distribution system. One of the other aspects we were working on is looking at benchmark systems. There are not a lot of systems out there where you can check your algorithms. And so we wanted to make sure we set up some different systems. And then we have basically the social impact that I mentioned earlier, is how will the public accept the things that we're talking about, as well as what are policy recommendations. Sometimes our systems rules may be set up for different types of systems. And so how do we make sure that our standards, our guides all take into account that? And then we have some lab demonstrations where we're doing things in the lab, and then we go out to some rural, urban, and semi-urban test cases to actually take our work here and put it out in the field. And then another really important part of UI Assist is looking at how do we develop the workforce. So how do we develop the workforce of tomorrow, but also how do we help the workforce of today deal with all these new technologies, with training, with tools to help folks be able to keep the power grid reliable and resilient. So from this, a lot of different aspects coming out here, and this kind of shows the interaction. You know, when we talk about, this is really, as power systems, we're talking about the system and a lot of different components inside that system. So That's one of the big things about our project. And this is really important as we start to look at the power grid is a system, but we're also interacting with transportation now as we look at electrifying transportation, as we look at possible green hydrogen and we as a fuel. You know, there's a lot of interaction between the power grid and other systems of systems. So just to get into a little bit of some of the field demonstrations and talk a little bit about how do we work some of these activities to look at resilience. So I'll first start these are our different pilots that we're working on across the US and India. And so what you see here are the different some of the different projects. And I'm just going to go through parts of these. You know, I could do the whole webinar on UISys, but I do want to talk about some other aspects as well. So, so these are some pilots that are being done by IIT Kanpur. Looking at one of the ones we'll talk more about is this rural village where 2 hamlets will have electricity. There's also, in the case of on the IIT Kanpur campus, they have some rooftop solar, and then also some activities in a residential tower to look at some different aspects of how to use storage, how to use renewables. And so this is an example of the neighborhoods in Kanpur where there's solar, there's been some batteries, storage put across the system, and basically as well as EV. And you can see the different aspects of this. And so what we're trying to do is test some of our theories in the field to make sure we understand, and we all know things make sense in the laboratory, but once we get them out there, and that's a really important part of UISys, is making sure we're getting out there. So this next slide right here, you can see me sitting right here in the upper right-hand corner with the ladies from the village that we are helping electrify. And this village, and you can see some of the ceremonies around that. We're providing some solar pumps to help, as well as a biodigester to help use the manure to be able to provide energy to the village as well. And so this is a really cool part of this project, is the fact that we're actually providing power using PV, using some storage to help a village with LED lights. And that's really been a neat part of our project, in addition to helping the existing grid, is seeing that we're actually providing power. But what's really interesting in this is if you are building a microgrid from scratch versus taking a distribution system and making a microgrid, there are different things you think about. And how can we learn from building this microgrid that things that as we start to modify the distribution system to look at microgrids? Also in the Delhi area, Terry is doing some urban pilots where they're using storage for a couple different reasons. Some is backup power, as you see here. Some of it's to help shift the energy and load requirements. And then some of it is for overload management, particularly looking at transformers where there may be some overload and being able to provide that. So these are just some examples of where by using batteries, you can have more resiliency related to backup power, but you can also shift the power on when you're using power by using the backup batteries that can help the system. In the US, we also have 3 pilots that are shown here. One is we're actually on our university campus in WSU Pullman, we're adding a battery that will help be back up to some of our critical systems. And that's one of the things when we start to talk about resiliency, we're not always talking about storage for the entire load. We're now talking about how do we control the load so we can have what's critical load and non-critical load and separate those. And then Avista, we're also Avista utility. It has a microgrid with a storage, with some solar, and they're looking at how do they also work on critical loads. And our partner at Texas A&M is looking at EV charging, looking at what they call a nano controller, and how they can have small nano grids that then work together to be an aggregator, and so you can actually control small grids that are part of a bigger grid. All right, so any questions? All right, so I'll keep going. So next we want to talk about the, this is just some examples, and if people are interested in learning more, you feel free to reach out to me. But one of the things we're working on is integrating the cyber physical nature, so that, you know, a lot of times we have the power system, and then we have the cyber communications in a different system. And so we work together to make a package called CP SysNet, excuse me, that is a package that allows you to add both the cyber layer as well as the power on top of the power system, so you can do analysis and look through that. And that's really going to be important as we move forward, is how do we integrate the systems together, because they're not necessarily separate systems, but they're integrated in solving our challenges. Another aspect that we have is looking at the different management systems of a microgrid versus a distribution system. And, you know, the energy management system has traditionally been for the transmission level. We talk about DMS or ADMS for the distribution level, but then we have the microgrid energy management system. And how do those work together? Because in some cases, part of the power grid might be, when it's attached to the system, it might be part of the ADMS, but then when it's detached, it might be the microgrid, the MEMS is controlling it. And then they're playing together in all those different times. So a lot of interesting aspects going on here about how to make sure we're communicating, how to work together to maintain reliability and resilience. And this can be reducing costs. This can be trying to reduce losses, and lots of different aspects related to resiliency as well as reliability. We also are looking at resilience. One of the important things is, how do you quantify resilience? And there's a lot of work that's been done in the last 5 years to help quantify that, because as you're to look at planning, and these are a couple tools that we work with that are to help with the planning aspect of how do you plan, where do you invest based on some information you have, and you only have a certain pot of money. How do you invest in maintenance? How do you invest in different areas to try to help increase your resilience later? And then the cyber physical aspect related to that as well is coming up with, where should you put sensors so that you have the best information on the ground? So there's a lot of different tools that we're pulling together as part of UI Assist. And then here is the data-driven, you know, looking at, this is at Hawaii, and looking at how are we able to forecast? One of the things is looking behind the meter. If we have solar on our house, then it's providing power that we don't really know how much power. And then how do we forecast the solar? How do we forecast cloud cover, and look at some of those? And we're also looking at machine learning aspects and AI-driven data. And that's really, by having all this data, we're able to make better decisions related to forecasting and predictions that help us have a more reliable and resilient grid. Another area is reliability, where we're trying to look at the differences in different parts of the U.S. And how that affects some of our different indices on safety and SAIDI, and looking at some of the different aspects of how energy storage will impact that across the U.S. And then kind of our last area I was going to mention is, well, two more areas. Volt VAR control. You know, how do we control where there are lots of different, you see up here, lots of different centralized, decentralized, distributed, hierarchical, hybrid, ... There's a lot of different, as we have distributed energy resources, how do we help control those and optimize those in order to stay resilient and also to have a reliable grid? And so we have a bunch of different activities going on in these different areas as well. And then markets, we're looking at different aspects of markets and how does a market, now that the distribution system has a lot of generation on that, how does that play in the transmission market? And how do those markets work together? We really don't have a lot of regulation in that in the US and India, and we need to be prepared for those marketing opportunities. So these are some of our test beds that we have across our US system to kind of look at and validate, and I showed you some of the field demonstrations. So really, we're just, some of the important things that we're seeing with this project is the collaboration across India and the US, the synergistic, also public and private, working with industry, and then of course the two hamlets. And we still have 1.5 years left in our project, so we hope to tell you more about that. But really, it's an opportunity, as we have seen a renewed interest in the US-India activities, it's really an opportunity for us to look at how do we work together to facilitate the reliable, resilient, affordable, clean energy supply in both the US and India by taking our UISys team and working with others in India and the US to help solve some of the problems that we see here. And particularly as we start to look at energy equity, electric vehicles, and other systems of systems. All right, so I'm going to stop here for a second. Any questions about that so far?
Hello, ma'am. I have a question.
Yes.
Ma'am, I think in slide 20, it is mentioned AHP. What is AHP? Can you just explain that? With regard to resiliency. 28, ma'am.
Oh, 28, sorry.
AHP.
So AHP is basically you're pulling together the I'm not exactly sure of what the acronym is here, but basically I think it's an optimization on looking at pulling all the data together to try to figure out what the resiliency is. So I don't know that off the top of my head. So I'll try to find that out and email me.
It's hierarchy process something. Hierarchy process something. I did.
What's that?
Analytic hierarchy process. Analytic hierarchy process.
Okay.
I think analytic hierarchy process something. I know. Maybe some. That's the factors. I think factors and weights just combined for resiliency.
Okay.
Yeah.
Thank you very much. Okay. Any other questions?
Yes, I have a simple question.
Okay.
These resilience are relatively new terminologies in the planning. Before we hear about security and reliability and all that, but resilience has come when climate change, global warming, natural disasters is all disturbing the power system. So I'm just interested to understand how we physically do a resilient analysis. What data do we have to for these studies? And can you show a simple system wherein we can bring in such data, and what will be the kind of results that we are getting out of these studies and analysis? Some small model wherein you can understand physically how this is applied in the real power system planning. That's all.
Yes. So that's a great question, and that's something that we've been trying to do is figure out. So typically, resiliency comes down in a lot of cases to investment and let me back up. So what happens is, at least in the US, we have some natural disaster and people are without power for a long time. And so then they're upset. And so they're like, well, we can do better than this. And so what happens is if you take, for instance, let's say you take a feeder of the grid and you look at the data on outages and you look at the reason behind those outages and you find that tree trimming may be a reason that you're having extra outages, or outages are taking longer than the average. And so then what you do is you say, well, we're going to invest in doing tree trimming more often in that area because that particular one area needs tree trimming more than another area. So in that case, it enables you to be more reliable, but also maybe get the lights on faster. So some of the data that's looked at is weather data and how the impact of weather on different equipment. You take that data, you pull it together, and you come up with some models on when you think a transmission line is going to get knocked down, what kind of speeds you need, what kind of issues might be around. And then you use a lot of simulations to look at, okay, this happens once in every 10 years, this happens once in any 20 years. And then, using lots of different simulations, you look at the different cases and see what you predict might happen. The other thing that can happen is, having a backup power supply or having a second connection to a part of the grid that enables you to have supply from two different ways, or having a reconfigurable part of the grid. And those costs related to that equipment, trying to predict where, if I don't have enough money for three remote controllable switches, where do I put those switches? And so I'm not sure I'm able to pull together, but if you reach out to me, I can send you some papers and some that show some of the different data that's looked at, and how do we use that data then to try to help decide how we do maintenance, how we do upgrades, where we do the upgrades, and some of those kind of decisions. So it's still a little bit of an art more than a science, but I think we're getting more and more aware, particularly with some of the data analytics, artificial intelligence, we're able to look at trends in that area and try to help predict what's going to happen.
And that will be very useful if you could provide some reference on how you really build a resilient network using the data, and that give you a good clarity of how you approach physically to solve an issue. Thank you, madam.
Yeah, and one of the challenges is every part of the world are a little bit different, right? And even in the US, we have some areas that have hurricanes, we have some areas that have wildfires, we have some that have tornadoes. And so some of the weather related events, and some of those events because of climate change are different than they were 20 years ago. So how do we look at a changing model of our weather and how that impacts that? But yes, if you, my emails will be at the end. So if you drop me an email, I'll send you some of those papers.
Yeah, okay. Power system classes need a new approach in addressing these kind of issues. These are very important these days. You cannot eliminate or avoid. You have to face it, and you should have the skill and knowledge to handle it. So I think we are looking forward to more references and more advice and support from you to understand the problem more deeply and resolve these issues ourselves. Thank you, madam.
Sure, thank you. All right, so I'm going to switch gears a little bit and talk about building resilience for you and also your leadership skills.
Ma'am,
and
one more
yes.
question is arising. Ashok, please.
Yeah, sir. Good evening, ma'am. Myself, Dr. Ashok.
Yes.
Ma'am, I have a question. How can we correlate this power grid reliability and resiliency?
Well, so that's a really good question related and so traditionally reliability, one of the things we have developed some metrics around reliability, right? How many minutes are outages? There's some metrics around both about distribution metrics that show us what we say as reliability. The challenge is resiliency is how do you respond? So when we talk about reliability, are the lights on or off, right? When we talk about resiliency, it's after there's an event, how long does it take us to get back to the lights being on? And so that's a different question related to how do we, when there is a change, how do we then get to that? And so traditionally reliability is the lights are on or off and their metrics there. But resiliency, we're saying there's an event, and should it take 1 minute to get back on? Should it take 10 minutes? Resiliency can also be that you don't have an outage because you could reconfigure. And so you can actually prevent a reliability issue because you are able to have backup storage. Or so there are two different aspects of resiliency being how do you respond to that event to help either reduce or eliminate, not have a challenge, reduce the challenge, or get your power back up as much as possible. So if you look at reliability, let's say we had a city and the lights go out. From a reliability standpoint, the lights are out so that the reliability is down. But then half the community gets lights. Their reliability now is better, right? Because their lights are on. But then you've also got the process on how do we get the lights on for the other folks, and how long did it take for us to get the lights on for the other group that didn't have power. And so resiliency really helps us be able to look at, can we prevent challenges, outages, and then B, how do we minimize the outages when they are larger and have are multifaceted, and we need to work with weather or large, looking at controlling different parts of the load so that we can have power to some. And really, if you look at reconfiguration, it is kind of a form of resiliency, right? We reconfigure to try to minimize. That's what protection does, is we're trying to minimize the impact of fault or outage. But now we're talking about that on a system level, is how do we reconfigure, what resources do we have in backup supply to keep the lights on, or to get the lights back on faster. Does that make sense?
Oh, one more, ma'am. One more question, ma'am. We
Okay.
have reliability matrices, reliability parameters, SciFi, SciD, KID,
Right.
so on, to ensure the power system reliability. Do we have the same fashion? Do we have any matrices to ensure power grid resiliency?
Well, there's a lot of research going into that right now to try to quantify that. But one of the challenge with resiliency is typically it's a dramatic event, right? So how do you, and it's kind of like insurance, right? If you buy insurance for a rainy day, if something bad happens, then you get some money. And that's what resiliency is about, is you are buying insurance, or you're doing a technical advancement to try to help when a challenge or disaster happens later. And so there's a lot of work being done right now on resiliency to try to figure out how to quantify that, how do you quantify, if I put up backup power in my if I have a manufacturing facility and I'm making, let's say I'm making chips, and I need backup power. How much does that backup power cost versus if my power goes out, how much does it cost? And so one of the challenges with resiliency is quantifying the value of the engineering in a financial way. How do I quantify if you have a UPS in your house and your lights go out, the grid goes out and you have power, how much value is that to you? And then you do it on a bigger scale with the power grid, how much value is that? And that's different in different parts of the world, and the expectations are different in different parts of the world. So that's right now, there's a lot of work going on how to quantify resiliency. And so that's something that's going on right now, and there are lots of papers in IEEE about that you can look at, and there are opportunities for you to get involved in that.
Thank you, ma'am. Thank you, Rahul.
Yeah, thank you. Now, and one
All
more,
right.
ma'am, you have taken the question or continue the presentation?
Hello.
Go ahead.
Hello. Yeah.
As I understand, as you stated that there is a direct correlation between the reliability and resiliency. Is that correct?
Well, reliability, I mean, obviously, if you don't have high reliability, you're not going to have high resiliency, right? Related to that. So I think when you're looking at reliability, there are kind of two different ways of describing. One is resiliency is really more about the bigger picture, and reliability tends to be the on and off aspect. But the on and off aspect of reliability is part of what we talk about. Let me go back here. Oops. Yeah. So, when we're talking about restoring, right, in this particular picture, we've got a resilient state. We have an outage, basically, typically. And let's say we have everybody's out, but then we turn the lights back on, then reliability, then the reliability indices are going to show that the lights are back on. Whoops, for this group of customers. And then here the lights are back on for this group of customers. And then here everybody lights are back on. So if you look at these three different states, you're going to have different reliability for those different areas based on this resilience curve. So there's a connection, but resilience as is defined on here is looking at reducing the magnitude and disruption. So if really it's it's increasing the reliability is what that is saying, that you're doing it to try to be able to work with that event. So resiliency is how do you increase reliability, but you do it in a calculated way, and not just by, that you look at the situation and how you can best add storage, add a reconfiguration capability, or some of the other features, and how do you make the grid more resilient? Does that answer your question?
Yes, I got it.
Thank you, ma'am. Is there any other questions? I think one more people in the queue.
I think Nilesh or someone has raised the hand. Do you have any questions?
Yeah, same question I have,
Yeah,
but now it's
Nilesh. Yeah, okay, Nilesh. Thank you.
Okay.
Yeah.
Well, we can go back to some of these questions when I'm done with a couple more slides. So, I'm going to talk about your resilience and reliability skills. And one of the things I think is important is the only constant is change. And I think how we deal with change as a leader and as an engineer and as a person is really important. And whether it's you individually or your team, it's important to look at how you deal with change and being able to deal with change. So a lot of times engineers are really comfortable about resilience to the power grid, but the question I have is, how do we engineer resilience into ourselves? And, you know, when I start to see a lot of engineers, they're more comfortable talking about power flow than they are talking about some of their other ways of being successful personally, dealing with challenges personally, some of dealing with many different aspects. So I want to talk a little bit about that. You know, obviously 2020 and 2021 have been years of resilience for us as people, as we've dealt with COVID, as we've dealt with, having not being out, having to stay home, having to learn online in some cases for universities. There's just been a lot of different things over the last 2 years. And so I think it's good for us to kind of look at what resilience means when we start to talk about people, not just power grids. And if you Google resilience, it says the capability to recover quickly from difficulties or a toughness. And then dictionary.com has, the power or ability to return to your original form after being bent, compressed, stretched, and to recover from illness, depression, adversity, or the like. And I like the analogy, if you have some grass and you step on it and it is deformed, but then you come back 30 minutes later, the grass is back up and it's rebounded. The 1620s definition is the act of rebounding with resilience. And as we talk about people, though, I think, what does resilience mean to you and me? And I really think it's not only the ability to recover, but to make a difference. So not just go back to zero, but to actually make things even better. And that's really what we're talking about with the power grid, is not only do we reduce the outages, but we also make the system even stronger. And these are some pictures. On the left are some women who were computer scientists and engineers at NASA in the United States and helped with some of the early, it's a movie called Hidden Figures, where they dealt with the challenges of being African-American women with engineers and scientists that didn't believe in them. And then we have Malala here, who also fought for women to go to school and even for some of her own health issues. And we all and these are people that showed resilience. They ran into a problem, they made a solution, and they worked to make it better. And so how about you? I want you to reflect a little bit about what you've learned over the last 2 years about yourself, about what new tools have you learned. We've learned that we can use Teams or Zoom or Google Meet and Greet, and we can see people. What other things have you learned over the last 2 years? And what about the team that you work with? What skills have you learned? How do we look back over the last 2 years and take the things we've learned and say, I'm going to use those moving forward? And there are things that I've learned over, being teaching online, that are some things that I think are going to be important for me to continue to do, even when we go back to whatever normal is. The other thing I think is really important, and this comes from a book called Lean In by Sheryl Sandberg. And this book is talking particularly about women work and the will to lead. But one of the things we're finding is it's not just women, but also all workers of today's generation are looking for balance between professional and personal activities. And so one of the challenges we have is defining success. So if we talk about a career ladder, a ladder that you see on the left, you go up, down, or you fall off. And the challenge is, A lot of careers nowadays, you may not have an up or down. You may have a parallel, or you may try something new. So you may go down. So she talks about really the jungle gym, making it a career jungle gym, where you think about how you might need a new skill. So you take a different job, and then that helps you climb to somewhere higher. And that you don't always have to be going up or down. You can go parallel, you can go up, you can go down and get different skills. So as we start to think about defining success, and particularly about being resilient in our careers, that we think about the jungle gym and how do we try different things, and not necessarily a ladder of just going up and down. The other challenge we have, we see sometimes in engineering, and is something called imposter syndrome. And you can go online and learn more about this. But even me today, and I'm 55 years old, and I sometimes don't have confidence in myself. And I think, well, am I good enough? Do I know enough? And so I doubt myself. And those are things, how do we become resilient to help us get successful through that? We see people start engineering and they don't make it through. And we know they could be very good engineers in our students. So how do we help understand some of that voice that's in your head? And we'll talk some about ways to deal with that. The other challenge we can often see is internalizing failure and saying, well, maybe I'm not good enough, when maybe it's you just need more confidence, or need a support structure. And these are things that affect our resilience as a person in our careers, in our family activities, and more. Persistence, which really, I think persistence is something that is really important when we talk about resilience. And how we deal with failure is even more important than how we deal with success. And I see, Thomas Edison here on the right. I haven't failed 700 times. I've succeeded in proving 700 ways that will not work. And so I think it's important as we look at, research is the process of going up alleys to see if they are blind. There are a lot of times we're going to run into challenges. I say resumes are really challenging. That there was a very nice bio that was read about me, and that talked about successes, but it didn't talk about the papers I didn't get, the jobs I didn't get, the disappointments I've had in my career. So along the way, we want you to make sure and put in perspective that you can do it. And when you run into those failures, look at those as opportunities to grow. So again, I want you to think about what things you've tried that worked, and what things you tried that didn't work, and what from those failures, what can you get, right? So if you, when we have on the electric grid, when we have something that doesn't work, we go and do an investigation and figure out why it didn't work to fix it for the next time. But I don't think we always do that for ourselves related to our fail. If we run into a problem, if something doesn't work, do we sit back and think about what would we do differently when we had things, and really think about, and I think COVID has really given us a chance to think about some of those things that we hadn't done in the past because we were busy doing other things. But I really encourage you to think about, when you have a failure or a disappointment, what do you learn from that, and use that in the next steps moving ahead. The other important thing is having support networks, and that can be family and friends, colleagues, mentors, networks, and organizations and clubs. And you're already part of that through IEEE PES and the different chapters and groups that are helping sponsor this lecture today. So, why should you network? And, one of the important things is to learn about new opportunities by talking to people, avoiding repeating mistakes, talking to people about the challenges, and then the lack of colleagues just like me. You know, as a woman in engineering, there are many times in my career that I've been the only woman in a room. And so finding that network, and you see a group here that was in Jaipur in December 2019 at a conference. So having those, you know, trying to network and find those colleagues that look like you. Opportunities for advancement. You can celebrate together, or you can be sad or cry together. And then I think it's important that you create a professional network, but also a personal network of people that can help support you along the way. So some of the benefits I've gotten from networking, my husband, I found was at a club at our university that I met. I've gotten new ideas. I've gotten job opportunities. I've gotten different perspectives, worldwide perspectives. Feedback, constructive feedback. People are able to encourage me. Leadership opportunities, support, parenting ideas, papers, proposals. All of those are things that I've had through networking and support in challenging times. So I really encourage you. I know we have a lot of virtual networks, but also to take advantage of face-to-face networks in helping you grow. And excuse me, I really think you should always have 3 networks. You should have a network on where you are. And so you can have a peer network of people that you work with. You think about mentors and a network on where you're going, but you should also have a network of where you are helping those that are where you've been. And think about your different networks and what you have and what you need to help you be successful as you're moving in your career. And IEEE PES has been an incredible network for me over my career, and I encourage you to take advantage of that. But networking is a proactive activity, so you have to continue to work along the way, and it's not something that it's kind of like plants. You have to water them and interact with them. You can't just let them go and they'll be okay. So, and to kind of reinforce that, you know, this is just kind of some of my path related to some of the organizations I was involved in: Society of Women Engineers, IEEE as a student, American Society for Engineering Education, and then IEEE PES. And I show on this where you start by being a subcommittee member, then you're a chair, then you get into other positions, and then you have opportunities to do it more and more leadership. So the next thing I would ask you to think about is, how are you learning and growing? You're here today, which shows that you're learning and growing and taking time for yourself for that. And then what opportunities are there for leadership, and how can you get involved? And also remember, sometimes you become a member and you do a great job, and then you have other opportunities in leadership and things like that. So I just want to challenge you to think about these things and use the IEEE PES as a place that you can learn and grow. The other thing is with mentors, and mentors are really part of networking. And, you know, I'd say one size doesn't fit all. If I have this dot here and I said I wanted to fit a line through that dot, I can fit any line through that dot, right? And so when we start to talk about, you know, if we want to interpolate or, you know, interpolate, you want to have lots of data. So I really encourage you to think about getting different mentors. Maybe one mentor is really good about, as a faculty member, one's really good about research, one's really good about teaching. So find different mentors. One's really good about writing papers, one's really good about writing proposals. Learn and get multiple mentors. Typically it's very hard to find one mentor that fits all. Be respectful of their time and try to get a diversity of thoughts. Try not to, sometimes it's easy to ask mentors that we think like us. Try to talk to others. Also look for mentors among your peers. Sometimes you can have peers that have a skill that you don't know, and maybe you have a skill they don't know, and you can do what I call mentor pairing or swapping skills. And sometimes you may be the mentor and sometimes you may be the mentee. So I really encourage you to think about those relationships to help you with your resiliency. One of the other really important things is to make sure we have role models and representation in leadership, and someone that looks like me. And I put some of the pictures of some of the leaders from IEEE and IEEE PES. Also, as some of the colleagues I've interacted with from India and Bangladesh. And, I think it's important that we have people that look like us in those leadership positions. So I encourage those to think about leadership positions and to have to have a seat at the table, to be able to be part of that leadership team. And then advancement. One of the other things is, you always want to encourage your colleagues for leadership positions and awards. A lot of times people don't always think they're ready for awards, so you want to work with them. And sometimes you're not comfortable promoting yourself. Maybe you got a new award and you're not sure how to promote it. You might think about getting a promotion partner that helps you think about that they will share with you about, they'll share with others about your successes, and then you can share about their successes. And that gives you an opportunity to really help each other and celebrate, just as I talked about earlier. So just to summarize, that, I encourage you to celebrate your successes from a resiliency standpoint. And there are many challenges are interdisciplinary, and really a diversity of thought is going to help. And I encourage you to continue to look at your personal resilience and leadership toolboxes and work with networks, and take some risks to gain other skills and have fun. And then we say go Cougs at Washington State University. So thank you very much.
Thank you, ma'am. If participants have any questions, either they can put in the chat box or you can unmute and ask.
Okay, can I stop sharing? There we go.
That was quite an inspiring talk. We have been immensely benefited by your leadership, your networking, your mentoring, all those skills. I'm sure we have to strengthen our network to be more strong mutually. And this topic is quite interesting, resilience, which is not applied practically as security analysis or reliability analysis. We have to learn to put this into practice. I'm sure you will be our mentor in applying this into real system. So I hope you will share with us more informative documents and standards, whatever is possible. And we are looking forward to associate with you in future in all new areas. Thank you very much, madam. Thank you very much.
Yeah, thank you very much to everybody for great questions, and I appreciate the invitation. And yes, I welcome an opportunity to connect, and maybe sometime soon I can come and sit in person.
Yeah, sure, ma'am. Is there any other questions and all? Ma'am, I have a question. Yeah.
Okay.
Ma'am, actually you told about AI techniques and application of resilience in a power system. So how much effective in resilience study now these days? But I saw some, I have gone through some papers of Anurag sir and some papers from WSU itself. So what about the chances of AI in resilience study?
Well, I think where AI is, we talk about machine learning, and there's so much data available from the power grid, and that's stored, and that's known, that if we can go through and use AI techniques, machine learning, data analytics to try to find those trends and find those that data, like the data I mentioned earlier about if we can look at what happened from a hurricane when it came in, and there's actually been work done looking at if it's coming in a different types of forests, how it affects the trees and different wind speeds and whether the impact of rain before wind. So some of it's not only the absolute values, but also the timing. Sorry, too much talking here. So I really encourage you to, that basically, I think that's where we're going to see that the AI and machine learning data analytics helps us look at data a different way to help identify things that may be hard for us. That if you look at three different, if you say, okay, is it wind speed, is it rain, is it the type of soil, if you look at all these different things, it's hard sometimes to come up with correlations as you look at it with the eye or even with some of our traditional tools. And I really think the data analytics will allow us to look at it in different ways and find some of those trends so we can come up with better models to predict. The same way you saw that we're using some machine learning for some of the solar. You saw the solar cells, right, going, and so we had some machine learning that was looking at predicting the way a cloud goes over and what that means to the grid. So I think that will all help.
Yeah, ma'am.
Sorry,
And
that,
one more final informal question, ma'am. Here
yes.
in our IEEE members itself, IEEE team itself, there are so many aspirants of doing MS, PhD, postdoc, doing in the US and all. So how can we initiate the process, and what message you can deliver to him? They have no hair.
That are interested in coming to the US?
Yeah, yeah.
You mean in general to graduate students, or you mean those that might want to
Uh,
travel to
There are so
US?
many BTech students are aspirants for MS, and here are MTech students in the power system itself. They are trying for writing TOEFL and all for getting the proper PhD position in the US itself. Uh, can you any other tips or message can tell?
Well, I think, one of the things that the challenge is we get lots of, so as a faculty member, I get lots of emails from people that say, I would like to, work with you. So I think it's important, that you try to identify, instead of sending it to a ton of different people, try to identify one or two people or a smaller group that you think you're really interested in. And then I would try to find ways to attend, like if it's something like this where if they're giving a webinar or something, you can go and hear them and then talk to them about maybe in online you can talk to them or interact with them. I think you can also maybe check with some of the students that are there and see if you have friends that are there. My grad students will come to me at times and say they have a friend who is interested in coming, and we'll try to help and connect them to somebody in the US in a particular area. So, I think be persistent. You have to be resilient. It's
Yeah.
challenging right now. With some of the funding being uncertain during COVID, I think as we're going to see an increase as the U.S. Congress is putting a bunch of money in infrastructure, we're going to see a lot of opportunities. So I think it's important to try to find out, you have to be persistent. Maybe even find out if the faculty member has office hours on Zoom that you can connect to. But I think if you can, one of the things that's important is to make sure that there are people in an area you want. Sometimes I get emails that say, Dr. Schulz, I see that you work in power electronics and I want to work with you. And I don't really work in power electronics. So it's kind of a letter that they just have sent to a bunch of different people. So I think if you can, and then in the email, the attachments, people don't always open attachments. So I would say it's important in your email to put some of your strength areas and then how you think they connect to what the papers are that professor has done. So I think those are some things that would be helpful. But I do anticipate an uptick in some of the activities in the US and funding opportunities as we start to move forward out of COVID.
Yeah, thank you, ma'am. On behalf of IEEE, PES, SBC, and ITC, I want to thank you, Pullman, and thank you for an insightful, a very much informative talk, ma'am. Thank you once again, ma'am, and thank you for coming have to our small platform. Thank you. Thanks a lot, ma'am.
Thank you all the
And thank you
best.
all for the participants too. Thank you for joining, and have a nice day, ma'am. Thank you.
Yes, and you can reach out to me in LinkedIn or email.
Sure, ma'am.
Take care.
Yeah, sure.
Thank you, ma'am. Thank you. Participants are requested to fill the feedback form. Thank you all.